thanks to ILP for organizing this session with a handful of colleagues working on different aspects of manufacturing and AI across MIT. So you'll hear from Fayez after me, and then Professor Chris Love, and then Dr. John Liu on the topics listed in the program. All right, so I will describe to you the vision for a new initiative at MIT called Manufacturing at MIT, whose goal is to build new campus-wide programming related to advanced manufacturing, engage with industry, engage with faculty and students, and help chart a vision for a future of production that I feel is really unique and special to what MIT can offer. And I have four main topics in my remarks. The first is some context, my personal perspective on where manufacturing has been and where it is going. Second, something about the history of manufacturing at MIT and how we got to this date. Third, some details of our efforts to build manufacturing at MIT. And fourth, a brief summary of an industry consortium that we are just getting off the ground and welcoming a final set of inaugural members before we launch in the springtime of next year. So you're here because you have interest in manufacturing, and I'm here because I love how manufacturing drives so many aspects of our daily lives, from raw materials to the most sophisticated finished products. And wherever you are, you can look around the room and look at the clothes you're wearing and the devices you're holding and realize how many things have been in factories and how manufacturing matters to so many aspects of our world and the future of our world. And as you also likely know, manufacturing has shaped the course of history. There was a time, hundreds of years ago, when single innovations changed the quality of human life, such as Gutenberg's printing press in the 1500s, and the invention of the Bessemer Siemens process for open hearth manufacturing of steel, which was a key starter of the Industrial Revolution. Now, perhaps we're at a time when there's not going to be one such singular innovation that changes the future of production, but I also feel that there hasn't been a fundamental innovation in manufacturing and how manufacturing has done in the past 100 years. Arguably, the most recent fundamental change was mass production, the Ford Motor Company's production system in around 1920, which led to the launch of the automotive industry. And if you look at some metrics, bear with my approximation here, between an automotive factory of the 1920s and a sophisticated production line now, you realize that while technology has advanced by orders of magnitude, and cars as a proxy for sophisticated systems are also much better and they're electrifying and changing, there's really been no change in the architecture of products and their connection to the complexity of the manufacturing process. Cars today versus 100 years ago have 10 times the number of parts, take 10 times the amount of time to come off the production line, and cost, on average, 10 times as much in adjusted dollars. So, why hasn't this changed? Well, I feel it hasn't changed because there have been no technology advances that have inserted effectively on the system level into both production systems and to the front-end design of new products. And this crisis of complexity, as I call it, managing more sophisticated product designs, coordinating supply chains both nationally and globally, is reflected in many other products. Look at smartphones, right? Our smartphones continue to advance, and here you see the housing of an iPhone 7 compared to an iPhone 12. Much more capable device, and of course, with a display, with a battery, with a processor. But if you just look at the mechanical architecture needed to advance the product performance, it's also more complicated, it's also more sophisticated. So my opinion, something has to change, and as we hear a lot about these days, the future of manufacturing is also coupled with the world's greatest challenges, addressing economic inequality, combating climate change, and with an important attention toward national security. And this is a bit of a slide of despair, right? Concern. But I'm really here because I feel there's a lot of hope and there's a lot of opportunity. That the time to rethink manufacturing and reinvest our intellectual and personal capital in a new definition of manufacturing is now. And I know you're from companies around the world, and this slide has a sort of more US focus, but I believe these trends are quite universal. You have governments around the world making new and big investments in advanced manufacturing, and you have the interest of the public and the private sector, industry and the investment community, believing in the importance of manufacturing for the reasons I described and more. So for the past couple of years, I've been leading an effort with colleagues to look at the history of manufacturing across MIT and chart a course for the future. So an interesting tidbit connected to the ILP is that the launch of, sort of say, formal, organized manufacturing research and industry engagement at MIT was about 40 years ago. The inaugural symposium of the Laboratory for Manufacturing and Productivity, which I direct, happened in 1978, co-hosted at Kresge Auditorium with the good old ILP. You may also know that at MIT we built some of the first CNC machines that transformed aerospace and defense production. And we had some of the world's first 3D printers built by Professor Ali Sachs and colleagues. But what I didn't realize when I came to MIT as faculty 10 years ago is that alongside the technology arc, there's also been an amazing arc of research in not only production systems, but the social sciences and the organizational structures that drive and transform manufacturing globally. And these include seminal studies like Made in America, the machine that changed the world, that unveiled the principle of lean production, and more recently, the production and the innovation economy and the work of the future studies. So one takeaway of why I feel MIT can play a big part in this new manufacturing is our symbiosis between the technology and the social sciences and how that leads to change outside of campus and in the real world. And I believe one measure of this, in addition to the many exciting technology areas, robotics, materials, AI, you name it, are the new companies that are being founded, have been founded in the Boston area and worldwide by MIT alums with interest in manufacturing. These include companies doing biomanufacturing, accelerating the process to develop new pharmaceuticals and bio-derived products, factory-scale additive and digital manufacturing technologies, fusion and other clean energy technologies, and the factory floor and supervisory level tools that are needed to make supply chains and factories more digital, more automated. And we have a really special connection between this interest in entrepreneurship, our ways of engaging with industry, and what our faculty and students do best, which is learn and do in the classroom and in the lab. So manufacturing at MIT is a vision for a campus-wide effort to establish new programs and partnerships that will help shape the future of production for innovation, growth, equity, and sustainability. And over this past 2 years, we've been looking at where manufacturing is at MIT now and how we can start to build a stronger community that really exposes manufacturing as a fabric across technical and social and management science disciplines. So here I'll tell you about a few things that we are doing, and then I'll talk about the future, where we're headed, and how we hope to engage some of you and your organizations along the way with us. So first, we've started a series of very high-profile events, a distinguished speaker series hosting CEOs and government leaders from around the world, and we've also held an annual symposium every springtime that brings together folks at MIT with external partners and industry collaborators to talk about the future of manufacturing, from policy to technology to sustainability. Second, we've taken a look at our curriculum in manufacturing and realized that we have a broad group of faculty across departments, including in my own department, mechanical engineering, that are teaching advanced manufacturing in a way that really reflects MIT's ethos, the combination of mind and hand. For instance, in our largest manufacturing class in mechanical engineering, we flipped the classroom. We created video lecture materials that the students watch ahead of time, and then in class, instead of watching a professor like myself point at the slides, the students do a hands-on activity and ask questions to one another and with the teaching staff. So here is a take-apart activity about injection molding in our manufacturing class where the students take apart a CNC toy. And we've also leaned into not just videos, but other emerging digital media for teaching, including virtual take-apart activities where you can disassemble electronic devices and inspect high-resolution metrology data on your tablet or on your phone. And if you're interacting with our courses from around the world through one of our open learning modules, you can inspect three-dimensional visualizations of parts and products also virtually. So we have a vision for campus and also a vision for engaging the world. Third, we're building some new manufacturing labs with the support of industry, with the support of the state of Massachusetts. Our initial focus is 2 facilities that will create end-to-end digital manufacturing capabilities, uniting advanced simulation, 3D printing, and traditional processing, all with a layer of augmented and virtual reality for training and for quality control. And these will be placed in the mechanical engineering department, the LMP, which I mentioned before, and in a facility in the MIT Nano building, Building 12, where that facility will focus on electronics and microfabrication. And we hope there are more facilities as we build our programs in different and complementary domains in the future. And fourth, perhaps something that faculty are most excited about, is a new large-scale research project to envision what we are calling this new manufacturing. It's a very vague term I'm using, but we're laying out a series of questions and say, okay, if we look at the technologies that are emerging in different domains, the general technologies, automation, AI, and robotics, and the ability to accelerate and sustainability and new materials, along with different industry domains, how can technologies be deployed faster? How can policy and investment instruments be informed? And what will the structure of firms look like in the future? Will there be more vertically integrated companies? Will there be fewer large companies and more small and medium businesses? And how will the overall connectivity change going forward? And we have a global focus and want to work around the world, but we also have a particular focus on the United States in this project as a kind of laboratory for thinking of how this new manufacturing can emerge. And we think about the world's most famous manufacturing companies of the past 50 and 100 years, such as TSMC, which arguably dominates semiconductor production globally and introduced the foundry model to the semiconductor production. And we incidentally hosted Morris Chang, the former chairman and founder of TSMC, just a few weeks ago, and he explained the trajectory of the semiconductor industry and how, to roughly quote him, TSMC just added the red line. But rethinking the relationship between production and access to production in semiconductors decades ago has shaped the evolution of one of the world's most important industries going forward. And we want to work closely with these companies and understand strategy and understand how the things we do best at MIT relate, and also understand the beautiful small and medium enterprises that represent this special sauce that makes manufacturing excel. And here I share an example of a pinball machine manufacturer, which is the world's largest pinball machine manufacturer based in suburban Chicago. And believe it or not, they manufacture 90% of the pinball machines, arcade games, if you will, that are distributed worldwide. And only 4% of their part content comes from outside the United States. They have 600 employees, and they do the full stack from design and licensing all the way to shipping sophisticated electromechanical products. And how do we encode the DNA of advanced design and manufacturing like this? And how do we reflect that on how we work with industry and how we do research that can lead to new technologies and more efficient production systems going forward? And there's also many, many startups, such as Vulcan Forms, which is building the world's largest additive manufacturing production facility just an hour west from here in Devens, Massachusetts. So putting all of these pieces together, what is manufacturing at MIT? I said it is a campus-wide effort to establish new partnerships and programs in these areas. And here's a perhaps too busy diagram of what it looks like to us at present. So consider a new initiative at MIT that stitches together manufacturing from across campus, works closely with the existing departments, labs, and centers that excel in the technical areas, excel in aviation and space manufacturing, semiconductors, rethinking the built environment, bio and chemical manufacturing, and you name it. Lays out a series of grand challenges, just overarching themes that touch all technical domains arguably, such as scaling new technologies and companies, building a stronger workforce, enhancing the resilience of our supply chains, and becoming more sustainable and circular in manufacturing. And then builds strong partnerships with industry through an industry alliance that I will describe, but also with government and policymakers, with other universities and community colleges and vocational schools that play a really important role in rebuilding our manufacturing workforce. And I mean those kinds of organizations, not just in the US, but also in other economies and emerging manufacturing economies. And the initiative will set up these programs and affiliations and build new activities, seed early stage research through the alliance that I will describe, help work with companies to define collaborative technology roadmaps, hold events and workshops, both broad and specific, catalyze entrepreneurship, introduce small companies to large, develop new educational programs for on campus and for the world, and build and operate new laboratories that our students and researchers will use, and also that will be available to industry to get access to advanced equipment and build prototypes. And we will have many partners across MIT. As ILP members, you're familiar with MIT as this hodgepodge of logos and acronyms, and it's not that manufacturing sits in a silo. We work with the Morningside Academy of Design, with the Climate and Sustainability Consortium, and with venture capital firms and other degree programs around campus. So now let me tell you, as I wrap up and hopefully have time for questions, about our industry alliance. And first of all, I'm not here to give you a sales pitch. I just want to tell you what we're doing. We really appreciate that you're members of ILP, and should you be really interested in manufacturing, we hope this is an opportunity for further conversation to understand your needs and your interest. But that said, the Manufacturing Industry Alliance or Industry Consortium will be a platform whereby we engage with leading global manufacturing companies and allow our members to engage with one another through advanced research, education and training, collaborative strategy, and through seeding and adopting technology via entrepreneurship. And here's a somewhat busy diagram of what engagement and membership in the Alliance will look like. We're in the process of recruiting founding members and plan to launch with a public event aligned with our annual symposium in April 2024. And we'll have different work streams. So first, you'll have a one-on-one engagement with us in manufacturing in the areas that are of strongest interest to your company. And this will include collaboration with a Master of Engineering program we have based in mechanical engineering, where each member will sponsor one team-based thesis project a year and host students on site, and also the opportunity to co-develop training programs that suit your manufacturing workforce or suit the professional audience in your company. And then through the grand challenges, the overall themes that I said before, our members will get together with our staff and with faculty and develop collaborative work streams. And this always looks to me kind of like a neural network, because that's what it is. It's getting interests and inputs and outputs together and figuring out the pathways where our members and individual companies collectively want to support early stage research in our labs, develop case studies, set up specific events, and form new partnerships. And for a little more detail on these three, like some other organizations at MIT, we will launch new seed research programs directed by members and on topics that are supported by our members. And these will be IP-bearing in a non-exclusive, royalty-free fashion. And these pictures are not representative of specific projects from the Alliance yet, because we're just getting started, but are representative of the topic areas that can be represented. Advanced materials for future manufacturing, robotics and automation, AI, as Fayez will speak about in a minute, scale up of new chemical processes, sustainable processes, and beyond the lab, studying technology adoption. For instance, what is the pathway by which firms from small to large implement automated production systems? What are the key drivers? What are the key inhibitors? And so on. So each member will have a role in supporting a seed research project as part of the portfolio of member activities. Second, I mentioned the engagement with thesis projects, and you'll have the opportunity to support a student team project in our Master of Engineering program in Advanced Manufacturing and Design. This is an existing program that we're putting together with our Industry Alliance, and to say it quickly, this program has educated hundreds of students over the past 15 years, many of whom are leaders of large, quote, new manufacturing companies. And this is a 12 to 18-month program, and on the 12-month track, the students take courses in the fall and spring, and starting in December and January, they ramp into industry engagement, and as a team, typically a team of 3 students, the team goes to the project sponsor company in the summer, works on site, and then completes their thesis project together on the subject that is defined in collaboration with the company. And last but not least, in the area of workforce training, you'll hear from Dr. John Liu at the end of the session, and he's developing a program that we call the Technologist Training Program, defining a new category of advanced manufacturing worker between the technician and between the engineer, someone who is trained both specifically in their domain of interest and generally in the overarching skills needed to adopt and work in advanced manufacturing. And this may not be exactly for you, or this may be a very specific area of interest where you need to upskill and attract new workers, and we're excited to pursue partnerships between our member companies and local educational institutions in proximity of their manufacturing facilities, and to provide digital learning materials that can be available online for free to facilitate more efficient, scalable workforce and technologist training. So going back to the overall chart, I hope this gives you a little bit of the complicated picture. And last, I'll mention that we'll have a leadership council where each member joins us in getting the organization off the ground and shaping the strategy. And it's really important that our founding members, our inaugural members, have a lasting seat at the table to help us shape this for the betterment of all. And we plan to launch in April. We like to keep track of things and manage the project. We're in the process of recruiting founding industry partners, and we will have an annual symposium along with the launch in April. And whether or not this interests you, ILP is always a tremendous partner, and we'll surely distribute the invitation to our annual symposium. And if you're around or able to fly into Boston, we hope to see you there. Thank you very much for your attention, and if there's time, I'd love to take questions.
Questions?
Thank you, very interesting. Are you able to share with us what the approximate fee structure might be for founding or other members of your symposium?
Yes, it's $275,000 a year, $250K for ILP members, and we ask for a 3-year commitment, though it's revocable with sufficient advance notice. Thanks for asking.
Thank you very much. Manufacturing should be considered in the design of the product. So the products,
right
that's really early on before you even get into manufacturing. So any comments? Is that?
Definitely, fully agree. And if you're asking like how would that relate to programming that we may offer, one of our ideas is sort of design manufacturing co-challenges to focus on different industries or different product categories and get new manufacturing technologies aligned with the approach for sustainable product design. Second, I think Fayez's presentation will be very interesting to you, just thinking of all the amazing tools that AI can bring us in the engineering context.
Great presentation. I have a quick question because most of the manufacturing discussions you talk about here is still, although some touch upon digital, but mostly we're talking about the physical world manufacturing, right? But now is a lot of discussion about like virtual reality, and
yes.
In those areas, is there any sense to talk about manufacturing in that virtual world?
Yeah, great question. Maybe you're thinking kind of far along the stream of actually, manufacturing in the metaverse, which is maybe interesting from a training perspective, right? So John Liu, who you'll see later, is working to develop interactive virtual reality simulation that we're using in open-ended manufacturing training. Second, there's a strong need for these virtual reality tools to simulate production systems, to virtualize factories as well. And one of our ongoing projects in my group is focused on optimizing factory configurations via simulation. So you can do kind of cost throughput analyses, or you can look at an existing factory and understand, if you add a new piece of new equipment here, or if you reconfigure, what are the other products that you could make from a perspective of not like, oh, this is a factory to make a faucet, but this is a factory to make metal components with certain properties and tolerances. And I firmly feel that the connection of the digital and the physical, or AI with process-based knowledge and new process capabilities will have the biggest impact on manufacturing in all areas going forward.
Great. Any other questions? I have a final one, John.
Go for it.
So when you look at manufacturing today, which is very discrete, so if you have to look forward into the future, are we going to see a different way, maybe an integrated manufacturing in the future, so that you build devices which come maybe on a molecular level?
Yeah, great question. New materials, new process technologies are being inserted in all kinds of products. So we have the capability now, as a society, as an industry, as an institute, to design materials from the molecular level, right? To design new polymers that can be more sustainable, to design new alloys that can be lighter and stronger. And also, I think really important is that we can take other considerations into account up front, like the carbon footprint, like the recyclability and so on. I also take your question as meaning getting it like that complexity comparison I made, if we can design better things ahead of time and use new processes, take 3D printing, for example, in some cases, we can get around this complexity by integrating more functionality in single components and bringing more sort of data-driven decision-making into the earlier stage of the product development process. And I think that's a way for integration or architecture simplification of the increasingly complex, like physical goods that are needed for everything we do.
Thank you.
All right, thank you. And last thing, if you want to chat at the end of the session, please look for me. You can also look for Julie Jopp, who's standing at the back and is the director of our initiative as well.
Super. Thank you. Thank you, John. Thank you very much.
Thank you.